We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Hey guys, Mr. Ng, your favorite math teacher here. Let's go over 4.5, general multiplication rule and tree diagrams. What's our learning target? Use the general multiplication rule to calculate probabilities. Use a tree diagram to model a chance process involving a sequence of events, so just another way of visualizing probabilities. And learning target number 3, calculate conditional probabilities using that tree diagram that we're going to learn how to do. Alright, for any chance process, the probability that events A and B occur can be found using the general multiplication rule. And then the general multiplication rule, where did my formula go? Here it is. It is the probability of A and B equals the probability of A times the probability that B given A has occurred. Now I'm going to do a little play on the lowercase n here. I kind of showed you guys that last time, but probability of A and B is the same thing as this. Okay, so we normally say this. This is read as probability of B given that A occurs. So remember we talked about in the last lesson that A needs to occur, then you're looking at B. Alright, let's go ahead and look at example number 1. Was there divine intervention for Tebow? Tim Tebow is an American football player who enjoyed tremendous success in the 2011-2012 season. In the 2012 Sporting News reported that 70% of U.S. adults had heard of Tim Tebow. And 43% of those who had heard of him believe that, quote, divine intervention was at least partly responsible for his success. Suppose that these results are accurate. Find that the probability that a randomly selected U.S. adult had heard of Tim Tebow and believe that divine intervention was at least partly responsible for his success. Show your work. Alright, so let's write that in words. We want the probability of heard Tim Tebow. Okay, there's the word and. We'll just call this one divine intervention. DI. Okay, so we want the probability of heard of who Tim Tebow is and divine intervention. Okay, based on what we've learned, that is equal to the probability that you heard of Tim Tebow. And if you look above, what does the and turn into? Whoops, my pen went out. that turns into what? Multiplication. And the probability is that, remember, this is kind of like the A, and this is the B. So now I'm stating the B, divine intervention, given that A has occurred. You've heard of Tim Tebow. Okay, so let's look at what percent of people who have heard of Tim Tebow. 70% have heard of Tim Tebow. Times, they've heard of Tim Tebow, right? That's this part first. They've heard of him, and then they also believed in divine intervention. So 43% there. And if you get your calculators and multiply those, you will get you'll get a probability of 0.301, which is a 30.1% chance that you will randomly find someone who has heard of Tim Tebow and believed in divine intervention as part of his success. Okay, that was learning target number 1. Let's move on to learning target number 2. A tree diagram shows a sample space of a chance process involving multiple stages. The probability of each outcome is shown on the corresponding branch. A tree branch of the tree. And then number 3, all probabilities after the first stage are conditional probabilities. I'm going to underline that because that's some difficulties for students, okay? I got 2 examples. 2? How many examples have I got? 3? I got 3 examples here. I'm going to go ahead and do one of those, and then you'll try one. Example 2A. Snoozer. Shannon hits the snooze button on her alarm 60% of the school days. So we're basically going to draw, let me read it and then we'll do it. If she hits snooze, there's a 70% probability that she makes it to her first class on time. If she doesn't hit snooze, she gets up right away. There is a 90% probability that she makes it to class on time. Suppose we select a school day at random and record whether Shannon hits the snooze button and whether she arrives in class on time. Example 2A, because I have 2 examples, and then the first part of it is draw a tree diagram to model this chance behavior. Okay, so we're just going to draw a tree diagram. Okay, so the first part I'm going to do is write the word snooze. And what's the probability that she hits snooze? This would be a 60% chance, so as a decimal, 0.60, that she's going to hit snooze button. So that's like a yes. Okay, and then from there, there's another probability here of 70%, because that's the next part, that she makes it to class on time. On time. Now this probability right here is that given she hits snooze, that she is on time. So again, that is given she hit snooze, yes, she has hit snooze, and she's on time. Okay, so as you think about this now, well, what's the probabilities we learned back in 4.1? These numbers have to equal what number? 100% or 1. So if you subtract 100 minus 70, you get what? 30. That means 30% of the time she's not on time, it's late. Okay? Okay, so again, what's the probability she hits? This one's kind of like yes, and this one is no. No basically means doesn't hit. Snooze button. Okay, remember the probabilities. 0.6 plus 40 equals 1.0 or 100%. Okay, now it tells us some information. It says if she doesn't hit the snooze, which what we just did in dark blue, and gets up right away, there's a 90% chance that she'll make it to class on time. 90%. Pretty good. Let's use a different color here. 90% that she will be on time. That'll also mean 0.90 plus what? 0.10 that she'll actually be late. Okay, so this is our tree diagram here. Okay, so what is the probability that Shannon hits the snooze button and is late for class on a randomly selected day? I'm going to use a highlighter here. Okay, so we want it where Shannon hits the snooze button. So I'm going to pen's not on, try again, there we go. Okay, we're going this path. Okay, she hits the snooze button and is late for class. Okay? Well, in those events, we're going to have to do what? We're going to have to multiply those. So let's go ahead and multiply those. So, the probability that she snoozes and late. So this would equal to the probability that she snoozes, and remember that turns into multiplication, and the probability that, pay attention, she is, given that she snoozes, that says snooze, I ran out of space, sorry, that she's late. Okay, not the late in the light blue, but the pink. Okay, so this path is 0.60, and it should have been pink, right, because that's 0.30. We're going to multiply those two together, and we're going to get an answer of 18. There's an 18% chance, I won't write it out, but 18% chance that Shannon hits the snooze button and she's still late, given that she snoozed the button. Okay? All right. Let's see what else we got. I'm going to put a bonus one in here. Don't have it on here. So let's just call this example 2.AC, kind of like a third example. What's the probability that Shannon presses snooze and is late, or the probability that she doesn't hit snooze, so I'll say no snooze, and is still late. So basically, this is just saying what's the probability that she's late. So let's write that. Basically, what's the probability that she's late? Well, snooze and late. Okay, probability of snooze is, we already calculated 0.60 times 0.30, right, which gave us 0.18. Now pay attention here. This is or. This was last lesson. That's a plus. Okay, probability that no snooze, so that would be 0.40. And, so that is multiplication, that she is late given no snooze, which would be 0.10. So basically that would be 0.4 times 0.10, which gives you 0.04. And if you add those numbers together, you get 0.22. So what's the probability that she is late? It would be about 22% of the time. Okay? All right. I want you to go ahead and press pause and go ahead and try one of these examples. Let's try this. For 2B, go ahead and draw your diagram and then press play. Draw your diagram and press play. All right, let's draw this diagram here. And as I read it, I'm going to go ahead and draw the tree diagram. Can you judge an ebook by its e-cover? Recently, Harris Interactive reported that 20% of millennials ages 18 to 36 25% of X-Geners, and 20% of baby boomers, and 17% of maturers read more ebooks than paperbacks. According to the U.S. Census Bureau, 34% of those are millennials. Okay, so let's go ahead and start. Let's see. These are people who responded to the survey. The survey. Okay, what kind of people we got? Okay, it's kind of confusing, but the second part is more accurate. 34% and over are millennials. So over here will be 34% are millennials. 22% are called X-Geners. Gen Xers, sorry. Gen Xers. 30% are baby boomers. And then they call that last group 40% are matures. Okay, so forgot to box all those. Okay, now let's go back up and see what it told us. It said 20% of these people, of the millennials, read ebooks. 20%. So I'm just going to write 0.20 reads ebooks. Okay, so that number would be then what? It's the complement of 20. It would be 1 minus 0.20, which is 0.80. No ebooks. Okay? All right, Gen Xers. 25% are reading ebooks. So 25 reads, and then 25 plus blank equals 100, that would be 75, so no reads. And we know that implies ebooks. Okay? Baby boomers are 21%. So 0.21 reads. And then to find the complement of that would be 0.79. Because again, those two numbers add up to be 1. And the last one, 17% matures reads, and the complement would be 83. No reads. Okay? So there's my tree diagram. Whoops, those numbers are wrong. 2B, B, that should be a B. Find the probability that a randomly chosen reads more ebooks than paper books. So I'm just going to call this probability that they just read ebooks. Okay? Now, if you think about this, this is basically going to be everyone that reads ebooks. Okay, so I would have to take in the millennials, that would be 0.20. So that would be 0.34 times 0.20. Because that is millennials. Or, did you get that? A Gen Xer reads is 0.22 times 0.25. So 0.22 times 0.25. Or a baby boomer, which is 30 and reads, that would be 0.21. So 0.30 times 0.21. Or, remember, or is plus, not multiplying here. A mature, which is 14 times 0.17. 0.14 times 0.17. And this would give us a probability of, I'll give you these numbers so you double check your work. This is 0.0680. 0.22 times 0.25 will give me 0.0550. This is 0.0630. And this one is 0.0238. You add those numbers up in orange and you'll get 20.98, okay? Or 20.98% of probability that you can get someone who's going to read an ebook. About 1 out of 5. All right, let's try. Oh, yeah, you were just supposed to try that one. Okay, learning target number 3. All right, learning target number 3 is conditional probabilities using the tree diagrams. And in 3A, we're going to do snoozing again and ask you to copy the flow chart from example 2A. So let's go back up here. Might be too big, but at least you have it. A little bit messy, but at least we have it on there. Okay. So now we got it. Suppose that Shannon is late for class on a random day. Okay. So let's write that. Probability that she is late. Okay. What's the probability that she hit the snooze button? Suppose that she is late. That's my condition. That's what I wanted to point out. There's the condition. So we want probability that she hit, sorry, I'm going to erase that part. So we want the probability that she hit snooze given, the given is the condition is late. So let me write that. That's our condition. That's our given condition. Okay, so this is late. The probability that she's late, given that she is hit snooze, and she's late. All right, let's look at the probabilities here. Okay, what's the probability that she hit snooze and is late? Okay, the word and is multiplication. She hit snooze, so that's 0.60 right there, plus, and she is late, 0.30. Okay, now, probability that she is late, let's see if I can erase some things that, well, it's the same thing, right? She's late if, let me see if I can go into different colors. She's late if she goes, it's not bright enough, green. She does not press snooze, but she is late. Okay, so I have to have both of those probabilities. So the probability that she's late, again, there's two ways. It's kind of like what we did in the previous problem. Does that make sense? It's she snoozes and late, or she pressed no snooze and is still late. That is 0.22. Okay, so if you wanted to, that is just 0.22 because that's from the last answer, and that was from the other example, those two. But I want to show you how I got that. That was 0.60 times 0.30 plus, why? Because there's two ways that she could have been late, 0.40 and 0.10. If you do that, then it would be 80.818, which is 81.8%. Suppose she is late, right? She's late to class. She's coming to Miss Ring's class late. What's the probability she hit the snooze button that morning? There's probably an 80% chance that she hit the snooze button. So what does that mean? Don't press the snooze button. Okay? All right. Once you guys go ahead and try example 3B, who reads ebooks? Do the same thing, copy and paste it, and then try the conditional probability using the tree diagram, and then we'll go over it together. Okay, this problem is just an extension of what we did in example 2BA, so I just copied and pasted there, and it's the same scenario, so let me just show you which one's the same scenario. Everything here in this boxed white. Same problem as above. Okay, here's the new part. A randomly selected U.S. adult reads more ebooks than hardcover books. So I'm just going to call that reads ebooks. Okay, that's the condition. Orange, condition. That is the given. Okay, if that is the given, my question is, where does that go? Does that go in the front or does that go in the back? Okay, so the conditions go in the back. So reads ebooks. Okay, what about in these particular conditions? This person, what's the probability that this person is a millennial? So given they read the ebook, what's the chances that this person is a millennial? Okay, let's write that out with a formula. So I have the probability that they read ebooks. Let's use pen, sorry. So what's the probability that they are, remember, if you look back at our formula from above, in the conditional branch, it's the probability of A times probability of B given that A has already happened. So if I go down here, I want the probability that someone is a millennial and that they read ebooks. Okay, let's get the orange one first. Okay, that one, remember, is just multiplication. So the probability that they are millennial in my diagram is 0.34. And the probability that they read ebook from there, right, I'm going along, is 0.20. Okay, now that I'm just going to use, if you think about this, the probability that they read an ebook is every single group. And we actually already calculated that in the previous problem. That was 0.2098. Okay, basically, again, you can just go back and watch that. I just got every group, millennials, Gen Xers, baby boomers, and matures, and those who had ebooks, I added them all up. So when I get that, that was 0.2098. And if you multiply the numerator, you'll get 0.068 divided by 0.2098, and you'll get 3241. There is a 32.41% chance, given that the person reads an ebook, that of that group, you select a millennial. Okay? All right. Example number 4, you guys try it, and then I'll go over it step by step. All right, review it all. Not milk. Lactose intolerance means you cannot tolerate lactose, ingredient in milk. Causes difficulty in digesting dairy products that contains lactose, a milk sugar. It is particularly common among people of African and Asian ancestry. In the United States, not including other groups and people who consider themselves belonging to more than one race, 82% of the population is white. Okay, so let's go ahead and just get that in there. Population. Pick someone from the population. There's an 82% chance that this person is white. Okay, what else do we got? 14% black. And 4% Asian. And you can always double check that those three numbers add up to 1. Okay, it says moreover, or more information, 15% of whites, 7% of blacks, and 9% of Asians are lactose intolerant. Okay, so I'm just going to make a abbreviation so this will go faster. And make sure you're defining your variables, right? Lactose intolerant, LI. Okay? So it says in white people, 15% are yes, they are lactose intolerant. Again, it means they can't have milk. 0.85, I got that number by just subtracting 15 from 100. No, they're not lactose intolerant. In blacks, 70% are lactose intolerant. That means this would be 0.30. No. Then the last one, 90%. And then no is what? 0.10. Okay, so that's our tree diagram. Okay, find the probability that the person is lactose intolerant. Okay, this means that the person can be This is a probability that the person is lactose, given that they're lactose intolerant, is white, plus that given they are lactose intolerant, that they are black, and given that they are lactose intolerant, that they are Asian. So you're just adding up those probabilities, okay? So I have 0.82 times 0.15. Now pay attention, and it's a plus here. This is multiplication that's plus, because you're saying, well, then the probability that the person is lactose intolerant given they're white is that probability. All right, so then we have black, which is 0.14, and yes, lactose, so 0.14 times 0.70, and Asian is 0.04 and 0.90. All right, so if you get these numbers, you will get 0.036, avocado color 0.098, and this one is going to be 0.123. So if you add all of those up, you will get a 0.257, which is 25.7%. What does that mean? There is a 25.7% probability that a randomly selected U.S. person is lactose intolerant. Intolerant, not tolerant. They can't tolerate it. They can't eat ice cream that's made from cow's milk, which some of my kids are lactose intolerant. But I can't. I love it. All right, 4C. Given that the chosen person is lactose intolerant, okay, so that's the given, that's the conditions. Let's make sure that's correct, right? Let's just use the same formula we did above. So the probability that they are already lactose intolerant. From there, what is the probability that he or she is Asian? Okay. And then how do we write out this formula? We learned that this one is probability that they are lactose intolerant. Okay, then we learned that the formula of the numerator is the probability that they are Asian. Let's just make that super clear. And lactose intolerant. So basically in today's lesson we learned that that is multiplication. So probability that they are Asian times the probability that they are lactose intolerant over that everybody they pick is lactose intolerant, right? So remember, we get that from above. All that math that we did above is how we found the probability that someone is lactose intolerant, which is 0.257. Okay, so probability that they are Asian and lactose intolerant was right here. There's the math. We already did it, which is 0.036. So you get 0.1401. So there is a 14.01% chance that a randomly selected person who is lactose intolerant, then there is a, sorry, let me try it again. Given that a randomly selected person is lactose intolerant, that's the given conditions, there is a 14.01% probability that the person is of Asian descent. What did we learn today? General multiplication rule, using the tree diagram to you can do this through Venn diagrams in two ways, and then lastly using conditional probabilities of tree diagrams. So that's lesson 4.5. Bye.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today.